So now we will study about the naming and formula of acids, how we can name the acids. So acid containing anions whose names end in "ide" are named by changing the "ide" ending to "ic", adding the prefix hydro to this anion name and following with the word acid. So let's see what is this rule. So basically acids are those who provide the hydrogen ion, they provide more hydrogen ion. Example, HCl, H2O, H2SO4, these are the example. So here, and every acid have one anion because every acid provide one positive ion. It means remaining ion will be, you can write like AH, or sorry, like that, HA. So when HA, you can represent HA as a acid. When HA will dissociate in the water, it will give you H plus and anion minus. So if anion have a chloride ion Cl minus, then how will you make its acid? Just add hydrogen on the left side, then it will become hydro because we are adding a hydrogen. Hydro is for hydrogen, and chloric. So you can see this ide, we are replacing this ide into ic. So this is the rule, says that acid containing anion whose name end in the ide, which is here, are named by changing the ide ending to ic and adding the prefix hydro to this anion name and following with the word acid. So we added hydro and change the ide into ic, remaining center word will remain same, chloro, and then we have to add acid. So hydrochloric acid, like this one. Another example is sulfide. So it's very easy. We have to add hydrogen, and why we added here 2? Because remember, we H plus have 1 and sulfur here have 2 minus, and when we will write its acid, so we have to cross over these charges as a subscript, and this will become H2S. And now we have balanced the charges also. So 2 hydrogen ion will give H plus and H plus. There are 2 positive ion, and sulfide have 2 minus. It means 2 minus will be balanced by 2 plus. So then the whole molecule will be neutral. So when we will write its name, we will add hydro, and center word will remain same, sulfur, and then ic. Rather than ide, we have to add ic and then acid. So this was the first rule about the naming of the acid. It's very easy. Whenever we have anion which have ide ending, you have to add hydrogen and then name as a hydro, and then ide will change into ic and then acid. So hydrochloric acid. Let's see the second example. Second rule for the naming of acid is acids containing anion whose name end in ate or ite are named by changing ate to ic and I to us, OUS, us, I to us, and then adding the word acid. So we have seen these anion, chloroanion. So with the perchlorate ion, where oxygen have 4 with the chlorine and it's minus 1 negative ion, when we added 1 hydrogen, this will become per perchloric acid. Here we are not adding hydro. This is the second rule, because when we have 8 at the rather than ide, if we have 8, it will change into ic. So 8 will change into ic. So here this perchlorate will change into perchloric acid. Another example is chlorate ion, again 8 will change into ic acid, chloric acid. And third example is chlorite, ite. So here ite will change into us. So it's chlorite anion. When it will form acid, it will form as a chlorous acid. And then hypochlorite will change as a hypochlorous acid. So this is the second rule for the naming of acids. If we have 8, it will be changing into ic, and if it has ite, it will change as us. And again we have to add acid. So this is the second rule for the naming of ion. Let's see one more. The third one is for polyatomic anions. Polyatomic anions containing oxygen have name ending either 8 or ite. Actually this is the same, almost same, but we will see some other examples in this case. In case of group 4, maximum 3 carbon oxygen atom in the period 2 and maximum 4 oxygen atom in period 3. So period is left to right. This is rows is called period, and we have studied in previous video that top to bottom columns are group and periods are from left to right rows. So in case of period number 2, any anion can form with the oxygen and can have maximum 3. So for an example, carbonate, nitrate ion. And in case of period 3 or group 5A, phosphorus come, then its anion, polyatomic anion will form. This is not correct. This is a nitrate ion. This name is not correct here. We have to correct this name. So basically this is phosphate ion, phosphate ion. Yeah, this name came here exactly same. So this is need to be corrected in the slide. Okay, so sulfate and then perchlorate. So whenever we make a acid of these anions, so you can see polyatomic anions containing oxygen have ending 8 or ite. So 8 representative oxy anion, 1 atom or fewer than represents. So when this anion will form acid, it will form H2CO3. This is called carbonic acid. So 8 will carbonic acid. So same rule as the previous one. 8 will change into ic. Similarly for NO3, this will become HNO3, and HNO3 is an acid which is nitric acid. This is nitric acid. And same way phosphoric acid, sulfuric acid, perchloric acid. So 8 will change into ic acid. In book there is one more slide. You can also learn this naming of acid from anion in this format also. If ide is there, it's kind of summary. Then add hydrogen, it will form hydro, and then center word will remain same, and then ic. So 8 will change into ic, and it will change into us. So this is the another way you can also make a table and then learning for different ways. So this was about the naming of polyatomic anions and acids. Now we will see few examples of naming of organic compound. So in case of organic compound, example here is an alkane. First example is an alkane. Alkane is a group name of a group. It's not a name of one compound. Alk is a prefix, and then ane is another suffix. So here is when one carbon have attached with the 4 hydrogen. Basically one carbon can attach with the 4 hydrogen or any other. It can bond. It can make a 4 bonds. And organic compound. So then it's called methane. Meth is one carbon, is called one carbon, and ane is coming from its group. And organic chemistry is the study of carbon, mainly all kinds of carbon compound are studied in organic compound chemistry. Organic chemistry has its own name of nomenclature, that is called IUPAC name, which we are not going to in detail here. The simplest hydrocarbon compounds containing only carbon and hydrogen are called alkanes. So what is the alkane meaning? Alkane meaning is the simplest hydrocarbon. Hydro means hydrogen and carbon. So the compound which made from hydrogen and carbon are called hydrocarbon, and the best their name group name is called alkane. So the first part of the name has just listed correspond to the number of carbon. For an example, meth is 1. Meth means 1 carbon. Here you can see there are 2 carbons, and every carbon has 4 bonds, 1, 2, 3, 4, and this carbon also 1, 2, 3, 4. So 2, if there are 2 carbons, so it called eth. Eth means 2 carbon. If there are 3 carbon, it's called prop, and there are 4 carbon, then in tetra, 5 is penta. So it's very simple prefixes. It is followed by ane. So methane, ethane, propane, tet. So like that. Yeah, if it has have 4 carbon, it's called butane, not tetra, it's called butane. And if it is a 5 carbon, it's called pentane or pent. Hexane, nonane, heptane. So the group of carbon and hydrogen is called alkane. General name is alkane. So you can remember and you can name organic compound by memorizing or reading this 2 lines, that if there is a 1 carbon, it's called, you have to use the prefix as a meth, and then you have to use as ane as a suffix. For 2 carbon eth, for 3 carbon prop. So let's see one more example of in case of organic compound. Alcohol. Alcohol we drink and We know beer and wine, so they all have alcohol. And the common alcohol which we drink, which is ethanol, not in the 100% form, but it's a kind of dilute form. We never drink methanol or propanol, they are toxic. And whenever have any methanol in the ethanol, it become toxic alcohol as well. So what is the alcohol? You have seen in previous slide that carbon have 4 bond when attached with the hydrogen, 4 hydrogen, it's called methane, right? Once you can replace this hydrogen with the OH group, then it become alcohol. So when a hydrogen in an alkane is replaced with something else, a functional group like OH in the compound above, the name is derived from the name of alkane, but they become alcohol. In case of ethane, you remember carbon is attached with the 3 hydrogen and another carbon, and then again 3 hydrogen. So each carbon is attached with the hydrogen and together by carbon bond also. So this was ethane, right? Ethane. So we have to use the same prefix eth. Rather than ane, we have to use all, ol, all, then become alcohol. So methanol, ethanol and propanol, 1 propanol. Why 1? Because this OH group is at 1 position, 1, 2, 3. There are 3 carbon and the OH group is attached to the first carbon, that is why we are putting 1 propanol. So the ending denote the type of compound. Alcohol ends in all. So here is one more example. If we attach this OH on this and third carbon, so this not become 3 propanol, because basically we have to start numbering from this side. Usually we start numbering of the carbon where the functional group is attached. So let's see if this OH group is attached in the carbon number 2, then what will be the name here? Carbon, hydrogen and hydrogen and hydrogen. So you can see I move this OH group from here to here, right? So now we cannot say like 1 2 1 2. We cannot say right this in numbering. So still numbering will be start from 1, 2 and 3, and the name of this alcohol will be 2 propanol. 2 propanol. So this is the very small short introduction about the organic compound alcohol and alkane. You will study more detail in the organic chemistry, OChem and O2. Let's see the one more last slide of this chapter is nomenclature of organic compound alcohol. When 2 or more molecules have the same chemical formula but the different structure, they are called isomers. For an example, I have shown you just in the previous slide that propanol you can write in the 2 different form, either 1 propanol or 2 propanol, right? So everything is same. 3 carbons are there, 3 carbons are there, hydrogens are 1 2 3 4 5 6 7 hydrogens are here, 1 2 3 4 5 6 7 hydrogens are here, OH is here, OH is here, everything is same, the position is different, right? So 1 propanol and 2 propanol have the oxygen atom connected to the different carbon atom, but both have the formula C3H8O. If you will count how many carbons are here in propanol, carbons are 3, hydrogens are 1 2 3 4 5 6 7, and then we will count this hydrogen as well, so this will be 8 and then oxygen will be 1. Same way carbon are here 1 2 3, hydrogen are 1, 2, 3, 4, 5, 6, 7, 8, and oxygen is 1. So both propanol 1 propanol and 2 propanol have the same chemical formula, only difference is in the functional group position. So these two 1 propanol and 2 propanol are called isomers. They are isomers to each other. And what is the isomer? So when two or more molecules have the same chemical formula but different structures, so they are called isomers. So 1 propanol 1 and propanol 2 are isomer, and these are the 3-dimensional ball and stick model that shows here OH group at the end of this carbon, and here OH group is attached in the center of the carbon. So this was all about the naming of organic compound and inorganic compound. So this was the last slide for this chapter number 2, and we will study about more in the 3rd chapter. So we will review those in the next slide. Hope you have understand these lectures, and if you have any question, please write in the comment box and I will try to answer your questions. Have a nice study.